7.1 definition of the Laplace transform. Laplace transform. Okay. Basic definition. If ft is defined for t is greater than 0, then we have what? We have this guy, 0 to infinity kst times ft dt, and this guy is equivalent to the b approach infinity ft dt. Now let's take a look at the formal definition. That's the basic definition, and the formal definition is like that. Let f be a function defined for t greater than 0, then the integral always say the symbol like that is Laplace transform. Okay, so next time when you see the symbol like that, means Laplace transform. Okay, Laplace transform of the function ft can be written down as like that, e to the power st ft dt. Okay, here the s is the parameters. Okay, t is the variables. Basically, well, what does the Laplace transform doing is transforming the t time domain to the frequency domain, represented by s. Okay, represented by s. So t is the time domain, and s is frequency domain. So transform the t to the s. That's the Laplace transformation. Is Laplace transform of f provided the integral converges. Okay. Convergence. Now, we can take a look at some symbols. People would like to write down the notation. They use the notation. For example, I do the Laplace transform of function ft, and then we can write down the Laplace transform function is fs. Okay, we denote this guy as capital Fs. we transform the time domain to the frequency domain, and this guy is capital Fs. And of course, Gt, we transform this guy to capital GS. YS and capital HT. This guy is little hs, little hs. Okay. Oh, yeah, we can use different. Oh, sorry. People usually use the little one for the time domain, and the capital for the frequency domain. And I think the definition is a little bit complicated because the integral is from the 0 to infinity. People usually don't like to do such a thing, but that's the definition, definition. However, that is a more convenient way for you guys to do the Laplace transform, because a lot of presidents already did such a transformation before. So we can use some properties to do the Laplace transform for other functions. Okay, so here I give you the theorem 7.1. Okay, I give you the transforms of some basic functions. Okay, and then you're gonna use these basic functions to calculate the Laplace transform of other functions. Okay, so let's take a look. Theorem. Transforms of some basic functions. The first one, A, one over S. B, this guy is S n plus 1. And C is this guy, e to the power at equals 1 over S minus A. D sine kt equals k s squared plus k squared. E cosine kt s divided by s squared plus k squared. F sine h kt, and this guy is k s squared minus k squared. G cosine h t Okay, how many? There are 7, right? There are 7 basic functions, transforms of 7 basic functions, like that. Okay, like that. So now let's take a look how to use these properties to calculate the Laplace transform. Okay, Laplace transform. Now, for example, the first example is here. Example 1. Calculate the Laplace transform of the constant 2. Okay, constant 2. So how to do it? Let's take a look. So Laplace transform, basically, we have the properties. If they are the constant, we always can put the constant out of the Laplace transform, like that. Okay, like that. 2 times 1, right? So we always can put these 2 out of this transform. Okay, why we can do that? Because based on definition, right? Based on definition, here the ft here the ft is 2, right? Here's a 2. You always can put a 2 out of the integral, right? When the ft is constant, you always can put the constant out of the integral, right? So basically, what you're gonna do, the integral is here, right? You do the integral for the function of the exponential function. The same things. So we can put the 2 out of pull these 2 out of this Laplace transform or out of the integral. That are gonna be this guy, right? This guy. And now you can use the formula. Okay, Laplace transform 1 means 1 over s. Okay, that's it. That's it. Okay, now I'm gonna give you guys some examples. Let you guys try it. Okay, try it by yourself. Okay, I give you guys 7 minutes. Here, t means you can find the formula here, right? Now try it by yourself. Okay, let me get on board. Okay. Now let's take a look at the first one. Laplace transform of pi. As we know, pi is constant, right? You can put pi out of the Laplace transform, right? So Laplace transform 1 is 1 over s. I times 1 over s. Right? Now, for this guy, Laplace transform of t is very clearly, we can use this function. So the exponent is what? Is 1, right? So that means 1 s 1 plus 1. Right? So 1 factorial gonna be 1, right? So we have 1 over s squared. Now let's take a look. The third one. And here n equals 2, right? N equals 2. It's gonna be 2 factorial divided by what? Divided by s 2 plus 1, right? 2 plus 1. So 2 factorial gonna be 2 times 1, right? So s cube. That's it. That's it. Now let's continue. Continue. Now I'm gonna give you guys several minutes to finish the Laplace transform of these two. Okay, and be careful. Here's addition. So for Laplace transform, actually we have the property like that. Okay, if we have two functions, ft, gt, actually we can write down as okay, fs plus gs for sum difference, sum and difference rule. Okay, sum difference rule. So for this question, we have two functions, right? We have two functions. Is that the sum rule? We can use the sum rule like that. Okay, so just let you guys finish it by yourself. Okay, finish it by yourself. Okay, let me write down the answer on board. So for the first one, here's a constant times t squared, right? You always can put a constant outside of Laplace transform. Okay, put the constant out of the Laplace transform. Okay, and then use the formula, right? We use the formula I show you. So t to the power n gonna be n factorial s 2 plus 1. And you're gonna get 3 times 2, 6. Okay. And for the second one, it's gonna be what? We're gonna spread it, spread it to 2 functions. Spread, right, using the property here, right? Using property, we can spread these 2 functions and do the Laplace transform of these 2 functions respectively, right? And don't change the sign. Here's the plus, right? Plus, put the plus here. If it is minus, just put a minus here, okay? And for the first one, it's very straightforward, write down like that, right? And then use the formula is what? 2 is 2 plus 1. And the Laplace transform of 1 is 1 over f, 1 over s, right? So this guy is 6. Okay. Now I'm gonna give you guys another example. How about this guy? How to do the Laplace transform of this guy? Very similar to the 2 functions, right? We just split these 3 functions to these 3 functions, right? These 3, spread these 3 times to 3 functions and do the Laplace transform for each term. 1, 2, 3, right? Here's 2 terms, 1, 2, right? There are 3 terms, 1, 2, 3, okay? Very similar. Just follow the property, okay? Follow the property. Laplace transform the first term, Laplace transform the second term, Laplace transform the last term, okay? Do it. Okay, let me write down the answer on board. So we have what? We have 3 terms, right? This time we have 3 terms. Split this function to 3 terms. Right? Just like this guy, right? We spread this function to 2 terms, ft and gt, and do the Laplace transform respectively. The same things. For if we have 3 terms, we spread this function to 3 functions or 3 terms and do the Laplace transform what? Respectively, right? And for the first one, sorry, it's 3. Okay, and then use the formula. We have a 3 factorial divided by 3 plus 1, right? 2 factorial 2 plus 1, and this one is 1 over s. Now that's gonna be what? 3 times 2 times 1, because 3 factorial gonna be 3 times 2 times 1, 2 power 4. Oh, sorry, that is s. Okay. And then you can simplify it for 1 over s. Okay, 1 over s. That's the answer. Okay. Now I'm gonna give you guys something else. Okay, something else. Example 8. Okay, try this one for me. Of course, you're gonna use the formula, right? Formula here, right? Here. Try it by yourself. Okay, now let me write down the answer on board. So let's take a look. For the formula, like I mentioned before, here for the first problems, what is A? A is -2, right? A is -2. So what are you gonna do? You just follow the formula. S minus A. A is -2. Right? That's it. And then it will boils down to 1 over s plus 2. And B, A is 3, right? That's it. Very straightforward, right? Now I'm gonna give you guys another example. Oh. Try this one. Here, the sum rule, right? We have two functions. So basically, two terms, right? So basically, you can spread the function to two terms, just like we did before, right? Like we did here, right? Did it here. Spread these two terms, and then do the Laplace transform for each term. Okay, each term. Go ahead. Okay, let me write down the answer on board. We can write down like that. Right? And then, because here's a constant, right? You always can put a constant outside of the Laplace transform. 2 times system, right? You can put a constant outside. 3 and t. And then you can use formula, right? A is here, A is -3. Here A is 5, right? A is 5. So gonna be 3 times 1 over s minus 5. You can simplify it. Okay, you can simplify it. And of course, if I do the combination, we can have like that. Okay, we can have like that. E. Okay, so what is the Laplace transform of this function? Is very clearly for this function we have 1, 2, 3, 4, 4 terms. So that means we're going to spread this function to 4 terms. Okay, and then do the Laplace transform for each term, right? For each term. So go ahead. Finish these problems, right? Spread the function to 4 terms. 1, 2, 3, 4, right? Go ahead, do it. Okay. You should. Okay, let me do it. Let me do it. Okay. I think it's not too hard. For this 4 times, we're gonna spread these 4 times, right? So let's take a look. All right, and then for this constant, okay, this constant out of this Laplace transform. And again, this guy gonna be A is a -2, right? A is -2. 4 t to the power 3 gonna be 3 factorial s 3 plus 1. Here is n is 1, right? S 1 plus 1, 1 minus s. Right? Let's follow the formula. You're gonna get x s plus 2, and here is 3 factorial gonna be 3 times 2, right? Times 1. 6 times 4, 24. Okay, that's it. That's it. Okay. Now let's continue. Example 9. I want you guys to finish this guy. Sine 3t b cosine 2t. Try these 2 for me. Okay. Again, go back to your table. Okay. Or the formula. Check the these 2. Go ahead. Okay, now let me write down the answer on board. So let's take a look. For this guy, we have what? Sine 3t, right? Sine 3t. So the sine 3t, k equals 3. So here, 3 s square, 3 square. Right. For sine 2t, will be k equals 2. Right. That's it. Now I'm gonna give you guys the combination. Try this one for me, okay? We have two functions or two terms. So we spread these two terms, right? Spread this function to two terms. So then we're gonna do the Laplace transform for each term, okay, respectively. Okay, I'm gonna write down the answer on board. I think it's not too hard. The first step, split this function to two terms, right? So we have and then like that, right? So now we can plug in the formula. Here the k is 4. So s squared plus 4 squared. Right? S squared plus 4 squared. And for this guy, sorry, I make mistake. No, that's right. So now here is k equals 3. Okay, k equals 3. So s divided by 3 squared. Okay, be careful. K squared, right? K squared. So we have what? 8, 16, 3s, s squared plus 9. That's it. That's it. Okay. Now I'm gonna give you guys the last two. Example 10. Is sine h. Okay, sorry. Sine h 2t B is cosine H 3t, cosine H 3t, okay? And basically we're gonna use the last two, right? Last two formula, F and a G, because here is about sine H, here is cosine H. Try it by yourself. Okay, let me do it on board. So here k is what? K is 2, right? So it should be s squared minus 2 squared. Gonna get to s squared minus 4. Very straightforward. Here's k is 3, right? So gonna be s squared minus 3 squared, right? Follow the formula. Now I'm gonna give you guys the last example. Okay. Now, if I give you this example, solve the Laplace transform. Okay. Basically, I combine everything, right? Constant, polynomial, exponential function, and cosine h. Try it by yourself. Okay. Okay. I think most of you guys should get it. Then you write down the answer on board. Okay. So let's take a look. Right, and then pull this constant out of Laplace transform. So t cosine h to t and the last one gonna be 2. Okay, so this guy gonna be a formula G, right? K equals 2, so it should be a 2 square. And this guy A equals -2, so S minus -2. And this guy T equals N equals 3 factorial. And this guy is 1 over S. Now you can simplify it. Okay, that's it.